So hello everyone, this is lecture 2 for the quantum mechanics. In the last lecture we were discussing about the contents we're gonna study in the quantum mechanics, and in this lecture also we will discuss about the contents only, because it has a quite vast syllabus for the quantum mechanics. So we discussed that we will study the postulates of quantum mechanics. In that we will study these 5 types of things. Means different type of postulate was about different things. So first was about states, operators, then eigenvalues, measurements, and the time evolution. So here the most important thing is measurements. So you need to understand very well the measurements in the quantum mechanics. Only then it will make you some sense. Okay, because this is the most important thing, which is means the application of quantum mechanics is importance with this measurements. Then we will see the means up to here this half of the quantum mechanics will be completed. Then whole half part is application of quantum mechanics. Okay, so in that we will study about the free particles. And what is the meaning of free particles? It means you have any electron or any particle, then net force is 0 on that. So we'll see the discreteness. We see that there is no discreteness in the energy of that particle. The particle's energy will be continuous. Okay, but when there is some force involved or the potential involved, then we will see the discreteness in the energy or the potential. So we'll study about that free particles. Then we will see about the potential step. This is like a potential step, means the particle is coming here, then there is some potential barrier, so it is a potential step. Then we will see the potential barrier. So this is kind of potential barrier. In the geometrical representation are these. So the potential barrier will see when energy is greater than V naught, and when energy is less than V naught, then what happened to the particle. So this is a very important part, because when energy is less than V naught, then we have the quantum tunneling. So we'll study more about it. Then we will see in the application also only the infinite square well potential, means in it there will be asymmetric potential well and the symmetric potential well. So in the asymmetry you will have 0 to L, infinity infinity, then minus L to L, symmetric potential well. Then we will see the finite square well potential. Here also in every case you will have the two types of energy greater than V naught, less than V naught. So when energy is greater than V naught in the finite square well, we will have the scattering solution, the bound state solutions here. So we'll study this. Then the most important thing, means according to the point of view of the exams, this harmonic oscillator, means this is a very important topic. Most of the questions asked from here, so we will spend a lot much time here. So in it we will study the half or harmonic oscillator also. So what is the meaning of half harmonic oscillator? In the harmonic oscillator we have this kind of potential curve, and in the half harmonic we have this kind of curve. So we'll study about this. Then we'll see 2D and 3D systems. So they involve the harmonic oscillator. So these are the very important parts from where we will study much. So particle in infinite potential well or box, 2D and 3D cases, harmonic oscillator in 2D and 3D, we will study about them. Then we will see the measurement of angular momentums. General or total angular momentum, we represent that by J. Orbital angular momentum, spin angular momentum, we will study them in the rotational symmetry. Then addition of angular momentum, we will study that also. Then we will see about the hydrogen atom a little bit in detail because this is a very important topic of quantum mechanics. Up to here only one particle was involved in the syllabus. Then we will have a multi-particles of the identity particles. We will see identical particles like fermions, bosons, we will study them. Then comes the approximation methods in the quantum mechanics. So approximation methods have the perturbation theory. So it involves two type of perturbation theory. We have the time independent one and the time dependent one. So what is the meaning of perturbation? That is the means there is some disturbance in the energy, is called the perturbation. So it's like in time independent, we have seen, it's like just put an atom in an electric field. Then we will see that if a normal atom has this kind of energy levels, then after putting in the electric field it will just deviate from it and it will be perturbed. So but if you have the DC source here, then a constant perturbation will be there, and it will not change with time. So it comes under the time independent perturbation theory. So it will be of two kinds, non-degenerate and the degenerate one. So all 1D cases will come in the non-degenerate, and the hydrogen atom 2D and 3D system will come in the degenerate system. So we'll see them in detail. Whereas if there is this AC source, then electric field will change according to time. Then we will have different levels, and the perturbation will change with time. So we'll have time dependent perturbation theory. Okay, just like if you applied this AC electric field, then it will change with time. So the perturbation will be time dependent. That's why time dependent perturbation theory we have. And when you have a hydrogen atom inside this DC source, then we observe the Stark effect. We'll see about this also. Then in the approximation method, we have also the variational methods. See, in this variational method, we use the trial wave function. Means this is for the systems where we don't know about the Schrodinger wave equation for a particle system. We can't find. So we assume a solution, and then we try to find the solution, and that's how it works. And this is the variational method where we assume a wave function. So that's how it works. We will see in detail this about. Then we see the WKB approximation. After it, we will see the scattering cross section, Born approximation, partial wave analysis. Okay, we will see about them. Then we will see about the relativistic quantum mechanics also. So this is not very much important according to the exam point of view, but according to the research, if you want to go in the research, then this is a very bright topic. So in it we will study about the limitations of Schrodinger wave equation when particle velocity is in relativistic regime. So how the equations are not valid when the velocity is nearby relativity. So we'll see that about, and we'll see more about the KG equations in this, and Dirac relativistic equations and spin concepts. So we'll study this, all the topics. I recommend you book, that is JEST, only that. Otherwise you don't need to go in other books, because you have to give the exam first, then you have to go in the research and all. So first only this book is recommended for your preparation. Otherwise these lectures and notes are enough, and I will provide you the solutions or the assignments or the previous year questions and all. So they will be enough to just crack the exam. So first your target should be to crack the exam. After that you have enough time to study more books like Griffiths and all. So these books are not recommended now. Now you are just focus on what I am trying to convey here. So from the next lecture we will start with our first topic, that is development of quantum mechanics from the black body radiation. So that's it for today.